Finally, let's return to tech because a UK firm has announced it has developed a quantum chip which can be mass-produced, potentially ushering in an era of far more powerful computing. Now, the idea of quantum computing is to use subatomic particles to store and manipulate data, allowing machines to solve far more complex problems than is currently possible. Well, joining me now is Dr. Chris Ballance, who is CEO of Oxford Ionics, and he's in California for us. Thank you very much for joining us. Tell us a little bit about what quantum computing is, because lots of people might not know what that means.
Good morning. So the past 70 years of computing has been dominated by small, incremental and steady improvements. And you might be, forgiven for thinking that all the problems we really want to solve, we can solve on today's immensely powerful computers. But this just isn't so. There's so many problems out there which we can write down the problem we want to solve, but we just can't come anywhere close to solving them on conventional computers. Even if we extrapolate the last 70 years of progress forward another 70 years, there's lots of problems we couldn't solve even given thousands of years of compute time. What quantum computers allow us to do is solve problems in a fundamentally different way and make a step change, a quantum leap, if you forgive the pun, in computing power. And this is incredibly exciting since there's so many problems out there that are going to make a really big difference if we can solve them effectively with these kind of computers.
So as somebody that uses a computer, how will my experience change?
So the way we'd use quantum computers is much the same way as we use supercomputers today. So as an end user, you won't really see a difference, but it just means things will get better and certain types of problems that we really, really want to solve. At the moment, people have to go and solve them in a lab, for example, building better batteries for really harnessing renewable energy properly. At the moment, we can't really do this without sending people into the labs to do tiresome repeat experiments. But we can write down the maths behind this, and on quantum computers, we can efficiently solve these kind of problems. So really, we should just see the world getting just that little bit better.
And how does it differ to AI? Because we hear a lot about companies investing in their artificial intelligence. Are we going to see now a shift, or does this fall under the same category?
It really forms under the same kind of category of new compute and finding new ways of taking the kind of problems we really want to solve that we currently have to solve by people doing really hard work by themselves and finding ways to make this more efficient. So quantum computing and artificial intelligence are quite separate, but they have much the same parallels of really being able to find ways of solving problems better by throwing completely new computational paradigms at them.
And in terms of globally, is there a race to do this better?
Yeah, there's a massive race. Now if you go around the world, there are hundreds of different companies trying to produce the best quantum computers, the best hardware out there. There's also hundreds of software companies. And if you go to all of the large corporates around the world, they'll all have teams working out in the same way as AI, how best to apply quantum computing to their workflows. And there's really the potential for massive disruption here in a very positive sense, because there's so many problems out there that currently we have to solve by people going into the lab and doing chemistry, for example, drug discovery, or for example, making better fertilizers, that we can solve much more efficiently with quantum computers.
Okay, and who do you think is going to win that race? You've done quite well here by achieving this mass production of the chips.
Yeah, our focus is trying to win this race and trying to win it by finding ways of producing these devices. And what we've now shown is not just that we've set performance records that are at an order of magnitude than the next nearest technology platform out there. That's pretty good by itself. But we've done this using chips that we can build in the same factories that already build chips for laptops and cell phones. And that's really what we've been pushing for the last couple of years of our existence, and it's a really exciting point to demonstrate this and make this public.
Okay, well, Dr. Chris Ballance of Oxford Ionics, thank you very much for joining us. Fascinating stuff, and best of luck with your venture.
Thank you.